Good morning, everyone. We are studying electricity question and answers, part 2. Question: a wire is 1 meter long, 0.2 millimeter diameter, and has resistance of 20 ohms. Calculate the resistivity of material. Answer for this: they have given of wire 1 meter long. L is equal to 1 meter. Diameter is 0.2 millimeter. If diameter 0.2 millimeter, the radius is diameter by 2, which is 0.2 by 2 is equal to 0.1 millimeter. Millimeter convert into meters, 0.1 into 10 power of minus 3. We can write 1 into 10 power of minus 4 meters. Has the resistance R is equal to 20 ohms. R is equal to 20 ohms. Now the resistivity of a material, how much? As per the formula, rho is equal to R into A by L. Now we know the radius. We need to calculate area. Area A is equal to pi R square. So pi value 3.14 into radius 1 into 10 power of minus 4 whole square. We need to substitute over here. Resistance 20 ohms into area 3.14 into 1 into 10 to the power of minus 4 whole square by length 1 meter. If you simplify it, 20 into 3.14 into 10 to the power of minus 4 whole square, 10 to the power of minus 8. So here 6 to 8, 1 0 will be there over here. After 2 decimals, 1 decimal. 62.8 into 10 to the power of minus 8 ohm meter is the answer. Hope this answer is clear to you. Next question. State Ohm's law. The resistance of a conductor is 1 ohm. What is meant by this statement? What is Ohm's law? Ohm's law, the relation between electric current, I, electric potential, V, electric resistance, R. So V is equal to IR is Ohm's law. The resistance of a conductor is 1 ohm. From that, R is equal to V by I. So resistance units 1 ohm is equal to 1 volt by 1 ampere is called as 1 ohm. Hope this answer is clear to you. Next question. Two electric bulbs A and B marked 220 volts 40 watt and 220 volts 60 watt respectively. Which one of the two has greater resistance? Answer here. There are the two bulbs A and B. A bulb having 40 watt, B bulb 60 watt. So both has connected to 220 volts, 220 volts. Power P is equal to voltage V. Here also power P of a bulb and voltage V. Now we can calculate individually electric current. As you know that P is equal to V into I is equal to P by V, which is 40 watts by 220, which is 4 by 22 is equal to 2 by 11. At the same way, B bulb I is equal to P by V, which is 60 by 220, 60 by 22 is equal to 3 by 11. Now, resistance we have to calculate. V is equal to IR, R is equal to V by I. So for the bulb A resistance, V value 220, by I value 2 by 11. B bulb resistance R is equal to V by I 220 by 3 by 11. You can write 220 into 11 by 2. Here 220 into 11 by 3. As you know that where the denominator is less, there the value will be more. So bulb A having more resistance has more resistance. Hope you got the answer. We are going for the next question. An electric lamp is marked 220 volts, 100 watt. It is used for 5 hours daily. Calculate the resistance while glowing. B question. Energy consumed in kilowatt hour per day. Now, electric bulb has marked with 220 volts, power 100 watts, time 5 hours. Calculate the resistance. As you know that P is equal to V into I. From that electric current we can calculate initially P by V, which is 100 by 220, 10 by 22 amperes. 10 by 22 amperes. We will solve it later. Now, V is equal to I into R. From that, R is equal to V by I. So, V value 220 by current value 10 by 22, which means 220 into 22 by 10. Here 0, 0 will be cancelled. 22 into 22. So answer here 484 ohms. This is the resistance while glowing. Now, total energy consumed. H is equal to P into T. So power how much? 100 into per day how many hours? 5 hours. Yes, 500 watt hours. 500 watt hours in kilowatt hour, 0.5 kilowatt hours per day, which is consumed. Hope this answer is clear. Next question. An electric iron of resistance 20 ohms takes a current of 5 amperes. Calculate the heat developed in 30 seconds. The resistance R is equal to 20 ohms. Take electric current I is equal to 5 amperes. Calculate the heat developed in 30 seconds. As you know that H is equal to P into T. So we need to calculate power P. P is equal to I square R. So I value 5 amperes. 5 square into 20 ohms, which is equal to 25 into 20 is equal to 500 watt. So 30 seconds, how many hours? So 30 by 3600 hours, which means 1 by 120 hours. So at the same time, hours you can complete it 1 by 120 hours. Now 500 by 120. 4.1 watt hours. This is under watt. Kilowatt or watt hours also can able to. Heat developed in 30 seconds. Hope it is clear to you. Next question. Calculate the current flowing through the resistor. Current we have to find out. Now you can see both the resistance is under parallel connection to the 4 volt. What is the total resultant resistance over here? Total resultant resistance answer for this question, 2 ohms and 4 ohms are in parallel. We have connected to 4 volts. Now across 2 ohms resistor, I is equal to V by R, which is 4 volts by 2 ohms is equal to 2 amperes of the current across 2 ohms. Across 4 ohms, I is equal to V by R, which is 4 volts by 4 is equal to 1 ampere. All right. Hope this answer is clear to you. An aluminum wire has the radius of 0.25 millimeters and the length of 75 meters. If the resistance of the wire is 10 ohms, calculate the resistivity of the aluminum. The resistivity of aluminum. Answer for this. A aluminum wire has the radius 0.25 millimeter. Convert into meters. 0.25 into 10 power of minus 3 meters. Or 25 into 10 power of minus 5 meters. The length of an aluminum wire 75 meters. If the resistance is 10 ohms, resistivity value how much? Rho is equal to RA by L. So 10 ohms into, here A value pi R square, which is 3.14 into 25 into 10 power of minus 5 whole square. So 3.14 into 25 into 25 into 10 power of minus 25. So 3.14 into 25 into 25 into 10 power of minus 25 by 75. Final answer is 0.84 into 10 power of minus 25 ohm meter. Hope it is clear to you. Next question. How would be the reading of voltage change if it is connected between B and C? Now you can see 1 ohm, 3 ohm, 2 ohms all are in series. The total resultant resistance is equal to 1 ohm plus 3 ohm plus 2 ohm is equal to 6 ohms. So the total current I is equal to V by R, which is 3 volt by 6 ohms is equal to 1 by 2 is equal to 0.5 amperes. Now, if the voltmeter connected to across BC, from that voltmeter reading how much? V is equal to I into R. I value 0.5 into 3 is equal to 1.5 volt across BC. Hope this answer is clear to you. Next question. 3 2 ohms resistors A, B, C are connected as shown in figure. Each of them dissipated energy and can withstand a maximum power of 18 watts without melting. Find the maximum current that can flow through 3 resistors. Now, here these 2 resistors under parallel. So 1 by R is equal to 1 by 2 plus 1 by 2 is equal to 1 ohm. R is equal to 1 ohm. and which is series with 2 ohms of a resistor. Total resultant resistance is 3 ohms. Now, maximum power P is equal to 18 watt. Find the maximum current they're asking. So P is equal to V into I. Now V is equal to I into R. So P is equal to I square R. So I square is equal to P by R. 18 watt by 3 is equal to 6 amperes. So I is equal to square root of 6 amperes. So this is maximum current through the circuits. Hope this answer is clear to you. Next question. A battery of 9 volt is connected in series with the resistors of 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms resistor. How much current would flow through the 12 ohms resistor? Now, the answer here. We need to connect all the resistors which is in series. Zero 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms, and 12 ohms are the 5 resistors. We have connected to 9 volts of the battery. Now total current is the same. Across 12 ohms or across 0.5 ohms or across any other resistor also, current value will be the same. So to find out the current value, the total resultant resistors which is in series RS is equal to 0.2 ohms plus 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms. Now 0.2 plus 0.3, 0.5, 0.5 plus 0.5, 1, 1.4, 13.4 ohms is the total resultant resistance. So V is equal to 9 volt. Now electric current I is equal to V by R, which is 9 volt by 13.4 ohms is equal to current value 0.67 amperes. Hope this answer is clear to you. Next question. A current of 5 amperes flows through a 12 ohms resistor. What is the rate at which heat energy is produced in the resistor? Now current I is equal to 5 amperes. Resistor R is equal to 12 ohms. So H is equal to P into T. What is the rate at which heat is produced? So H by T is equal to how much? Let's say P. P in the form of I and R. I square R, which is 25 into 12. That is equal to 300. 300 heat energy, the rate of heat energy. Joule per second is the units. Thank you very much.